All right, welcome to the Unit 7 test review on radicals, imaginary numbers, solving radicals. I'm going to go through the review pretty quickly. There's 25 problems, so let's get right into it. The first problem says simplify each expression and the instructions for the first one. So what we're looking to do is to simplify this. Most of you are most comfortable doing this via the factor tree. So that's the route I'll go on this. And remember, when we do this via factor tree, we're looking for pairs. So originally we had a 4 out front. And we get 2 pair of 2's that come out. We get 3 x's that come out. And 2 and x didn't find a partner. And so we should wind up with 16x cubed times the square root of 2x. All right, for this problem, we're just going to multiply out. So we'll get 4 times negative 5 times 2 will give me negative 40. And then I times I times I is I cubed. But remember, I cubed is really negative I. We never leave I raised to a power in the answer. And a negative times a negative is a positive, so I will get 40I. All right, for number 3 is a little tricky. We can't have a radical in the denominator. But I can't just multiply by the square root of 3 because the square root is being added to a rational number. So the only way to get rid of the radical is to multiply by the conjugate. We multiply the top and bottom by the conjugate. It's the same thing, but instead of minus the square root of 3, it's plus the square root of 3. We distribute on the top and we'll get 16 plus 2 times the square root of 3, and that's pretty straightforward. On the bottom, we'll FOIL, and we'll get 64 plus 8 times the square root of 3 minus 8 times the square root of 3 minus 3. Or 16 plus 2 times the square root of 3. And the reason we multiply by the conjugate is because if you notice, this term and this term will cancel, and we'll be left with 61. And that's your final answer. We no longer have an irrational number in the denominator. All right. Now, we can multiply things that are inside the radicals, but we cannot add them. The only thing we can do is add what are known as like radicals. And so here, what we'll do is we'll simplify each one of these radicals. So the square root of 3 plus 3 times the square root of 3 plus 3 times the square root of 6. And here's where like radicals comes in. These are like radicals, so 1 times the square root of 3 plus 3 times the square root of 3 is 4 times the square root of 3 plus 3 times the square root of 6. And that's our final answer. We cannot add the square root of 3 to the square root of 6. So this is another one of those ones that if we do it correctly, we're going to FOIL it out. Remember, though, that if you have your calculator set to A plus BI in the main mode menu, that the calculator will most likely do this for you if you just type it in, like we practiced in class today. So if we're going to do it correctly, though, we're going to FOIL. And so we'll get 8 plus 14i, 8 plus 28i plus 2i plus 7i squared. So it's going to be 8 plus 30i plus 7 times negative 1. Because remember, one of our key facts is that I squared equals negative 1. So this will be 8 minus 7 plus 30i, or 1 plus 30i. Number 6 could not be simpler. The problem is that this is once again one you can type directly into the calculator. But to do it correctly, remember our rule that the square root of a times b equals the square root of a. So in here, the math that's really going on is this is the square root of is negative 1 times 81, or the square root of negative 1 times the square root of 81. Remember, I equals the square root of negative 1. So this is just I times 9, or 9i. Most of us will not do all the steps. We'll just simply say, we'll go right from here to putting the I out front, and then the square root of 81 is 9, and we'll go 9i. And that's fine. I'm just showing the underlying math that's going on. All right. So for number 7 is very much like number 3 in that we're not allowed to have an imaginary number in the denominator of our fraction. But I can't just multiply by I because it's being added. So once again, I'm going to have to multiply by the conjugate, which is 5 minus 3i. We'll distribute across the top, and I'll get 20i minus 12i squared over 25 minus 15i plus 15i minus 9i squared. Once again, the outer and the inner terms of our FOIL will cancel, and we'll end up with 20i plus 12, because remember, I squared equals negative 1, over 25 plus 9. Or, remember, we should always write our real number first. Now, this is almost done, but this fraction can be reduced. We can divide the top and bottom by 2, and we'll get 6 plus 10i over 17. And that's how I would expect the answer to look on the SOL. If you wrote it as separate fractions like this, which is what you get on your calculator if you type the original problem in and then do math, enter, enter, that would be fine as well. We just need to realize that this and this are the same. Number 8 is just another foiling problem. So 32 minus 4 times the square root of 7 plus 8 times the square root of 5 minus the square root of 35. There are no like radicals, so believe it or not, that is your final answer. You just FOIL it. No like terms to combine, so we'll leave it alone. All right, number 9 is one that is a common mistake, is people say, oh, well, I just square this and I square this and I'll get 5 minus 7, I'll get negative 2. That is incorrect. That is not correct. Remember that we're squaring everything inside the parentheses, so this is really the square root of 5 minus the square root of 7 times the square root of 5 minus the square root of 7. So what you'll end up with is 5 minus the square root of 35 minus the square root of 35 plus 7, or 12 minus 2 times the square root of 35. Remember, by definition, any square root times itself is the radicand. So the square root of 5 times the square root of 5 is 5. The square root of 7 times the square root of 7 is 7. All right, for number 10, there's 2 different ways you could attack this problem, so we'll show both ways. Do it twice here on the same screen. So the first way you could do it is you could just multiply the outsides and multiply the insides. And then break this down. This is 6 and 10, which is 2. I'm sorry, and 100, which is 2 and 3, which is 10 and 10. And I can keep breaking this down, but remember I told you if you get a pair of stuff, stop. So this is just going to be 150 times the square root of 6. The other thing you could do is, if you wanted to, is you could break this down first. And I'd get 6 times the square root of 5 times 5 times the square root of 30. Sorry, the smart board's a little bit off. And you'd get 30 times the square root of 150. And you break that down into 5, 15, and 10, which is 3 and 5 and 5 and 2. And then there's your 150 times the square root of 6. So you can break it down, then multiply, or you can multiply and then break it down. Either way, you'll get the same answer. For number 11, the common mistake on this problem is everybody's going to try and FOIL it. And we forget what this symbol is right here, which it says add. And so this problem really could not be easier. Negative 2 plus 15 is 13, and 3i plus negative 5i is negative 2i. Just combine like terms. For number 12, all right, this is different because of the index. This is not a square root, this is a cube root. So instead of, we do the same thing we did before, we're going to break it down. We'll go, this is 8 and 8, which is 4 and 2, which is 2 and 4, which is 2 and 2. And then the t's and the w. Now remember, since this is a cube root, we're not looking for pairs, we're looking for triples. So we'll end up as 2 times t cubed. And the w didn't find a partner, so he has to stay behind. And here's the important part, is do not forget to write in the index there. So this is going to be 4t cubed times the cube root of w. All right, I to the 40th. So remember, that's going to be I to the 4th to the 10th power. Remember, I to the 4th equals 1, so this is really just 1 to the 10th power, or 1. The other trick I showed you is you can just take the denominator and, take the exponent and divide it by 40. You get 1. And you get a remainder of 0. If you raise I to the 0th power, that's also 1. So you can, if you do long division and just raise I to the remainder, that will give you the correct answer as well. All right, for 14, the common mistake here is to multiply -5 and -45 and get positive 225, take the square root and get positive 15. But remember, the rule was we can't evaluate these until we get the negatives out. So it's going to be I times the square root of 5 times I times the square root of 45, which will give me I squared times the square root of 225, or -1 times 15, or -15. If we didn't pull the i's out, we'd get positive 15, and that would be the incorrect answer. All right, I know this one scares everybody all to get out because it's got fractions, it's got negatives, it's got all kinds of craziness. But let's just review. If I had x to the 7th over x to the -3rd, that would be x to the 7th minus -3, or x to the 10th. So this the same thing is going to happen here. This is going to be x to the 2/3 minus -3/4. Here's one where if you can't do these fractions, you can always do them on the calculator. Multiply top and bottom by 4, that'll give me 8/12 plus 9/12, or x to the 17th 12. All right, this is one of the ones where it helps to remember your rational exponents, is you could write this as k over 6 to the ninth. Remember, the index becomes the denominator of the fraction. And then I can reduce that to k to the 2/3. And this is the correct answer. But on the SOL or any test, if the original answer came in radical form, then the answer choice in the multiple choice is probably also going to be in radical form. It's the same thing. We put the 3 back into the index. Remember, this is not that. The 3 does not go out front. The 3 goes in the index. Next problem, number 17. So we're just going to raise this 16 to the 1/4 x to the 12/4 over 81 to the 1/4. And if you did this, what you'd find is that 16 to the 1/4 is 2, 12 over 4 is 3, and 84 to the 1/4 is 3. All right, this is a tricky one because we have a radical in the denominator, which is not allowed, but it's not a square root, it's a cube root. So how do we deal with a cube root? Remember, we're looking for 3 of them. So I'm going to multiply this by the cube root of 3 times 3. And that way when I multiply it all together, I'll have 3 3's. But if you think about it, 3 times 3 is 9. So I'm multiplying the top and bottom by the same. And I'll end up with 4 times the cube root of 9 over 3. All right, number 19. This is probably the hardest problem on the review. It's a little long, but it is doable. Now, we have radicals on both sides. I can only isolate one of them. So I'm going to square both sides of the equation. This will give me n minus 7 equals, and unfortunately I'm going to have to FOIL 7 minus the square root of n times 7 minus the square root of n. And I will get 49 minus 14 times the square root of n plus 2n. I didn't write out all the steps, I FOILed, that's what you'll get. So now I need to isolate this radical. So how do I do that? Well, I'm going to subtract n from both sides. Now I have negative 7 equals 49 minus 14 times the square root of n. I'll subtract, whoops. I will subtract 49 from both sides. And now I'll have negative 56. Double check my math there. Equals negative 14 times the square root of n. I'll divide both sides by negative 14. And now I will have 4 equals the square root of n. Now I've isolated the other radical. So what I'm going to need to do is to square both sides, and I'll get 16 equals n. Now remember, if we square both sides of an equation in the process of getting our solution, we have to plug that solution back in to double check that it works. So because we can get extraneous solutions. So 16 minus 7 has to equal 7 minus the square root of 16. And this is going to be the square root of 9 equals 7 minus 4, or 3 equals 3. Our double check works. 16, n equals 16 is in fact the solution. The other solving problems aren't quite as bad. Here, remember, you have to isolate the radical first. So we're going to add 11 to both sides, and I'll get the square root of 2x plus 5 equals 4. Now I have the radical isolated. I can square both sides, and I'll get 2x plus 5 equals 16. I'll subtract 5 from both sides, and I'll get 2x equals 11. Divide both sides by 2, and I will get x equals 5.5, or 11 over 2. I'd accept either of those answers. Number 21. All right, once again, this rational exponent is the same as a radical, I need to isolate it first. So I'll get 4x minus 5 to the 1/3 power equals 3. So in order to get rid of the 1/3 power, I will cube both sides. And I'll get 4x minus 5 equals 27. Add 5 to both sides, I'll get 4x equals 32. Divide both sides by 4, and I'll get x equals 8. You can plug it back in, it works. Number 22, I need to isolate the x squared. So, first I'm going to subtract 42 from both sides, and I'll get 7x squared equals negative 42. Divide both sides by 7, and I'll get x squared equals negative 6. So in order to get rid of the x squared, I'm going to take the square root of both sides. But the key difference is, remember, when you take the square root of both sides, one side will become plus or minus. So this will become x, and over here I can pull the negative out and turn it into an I, and I'll get x equals plus or minus I times the square root of 6. All right, number 23 is supposed to resemble the type of problem that we could see on an SOL. And the key thing is here. Circle all of the following. Please read problems when they're given to you. All, which means that there's probably more than one right answer here. This is I to the 13th. And if you use our trick from earlier, this is I to the 1st, or I. So that's the same as I. This is the square root of negative 1, which is defined as I. I to the 37th, using our trick from earlier, is going to be 37. It's going to be a remainder of 1, so that's I to the 1st, so that is also I. This one, when we multiply this out, we're going to get 1 minus 2I plus I squared, or 1 minus 2I minus 1, or negative 2I. So that one's no good. And if we divide 19 by 4, I will get 4, I get a remainder of 3, that's I to the 3rd, that's negative I. So that's not equal either. All right, convert the radical expression to one with a rational exponent. Remember, the number implied, if there's nothing written in a radical, is 2. So this is 8 to the 1/2, x to the 5/2, y to the 6/2. Or 8 to the 1/2, x to the 5/2, y to the 3rd. Sorry about the bell, I'm doing this during lunch. All right, so this last one says convert the expression with a rational exponent to a radical. The problem is that we have, let me see if I can, I don't know if I can make that any bigger, is that I have two different denominators. So what I'm going to do is I'm going to rewrite it so that they have the same denominator. And I'm sorry, 1/3 and 2/6 are the same. We have to find the common denominator and change it. So this is going to be 3 times the 6th root of x squared y to the 5th. I went through this quickly to try and keep the video from being forever. Feel free to rewind, pause, and if I went too fast, come to class with a question and we'll answer before we take the test. Good luck, and I'll see you when we take the test.